there's been a huge impact by these technologies for rare diseases altogether and for genetic rare diseases in particular, so that many new therapies can be developed that previously had been impossible. One indication for this was, of course, last year's effort for a bespoke therapy for a baby with the metabolic disease, where specifically for that patient, for that mutation, so a very specific defect, gene editing tools were developed, were tested in mice, were validated, and were then applied to the baby within a 6 months time period, because otherwise the baby would have likely died, as an exemplary effort and as an indication of what is possible if everything is put behind one of these cases, one of these efforts. Now the specific bespoke assay and bespoke effort that was done, that cannot be repeated for everybody because it would not be sustainable. Okay, but it indicates just like a concept car, let's say for the car industry and so on, it indicates what will be logical, what will be feasible, maybe in 2, 5, or 10 years' time. So if this is now an effort that needs extra funding, needs extra coordination and extra attention, then it is something that in 5 years or so might be more routine. It might be more logical to perform. Okay, so through these new technologies, for genome editing in particular, now there's a lot of hope for rare disease patients because we can see what can be done, and enormously effective therapies can be developed with this. At the moment, the cost is a major issue. Bringing all the expertise together, that's a major issue. But for things that I might mention now, the cost will probably drop, and the expertise is being built up worldwide. So it is something that is now not an if, and it's not sci-fi. It is something that is really a reality that is now a question of time, merely, and not a question of if it's going to happen at all. Okay, so for the genome editing field, the last 10 years have seen enormous development with the advent of the CRISPR-Cas technology, which it's difficult to explain to lay people, but it is so much easier to apply. It is so much more cost-effective to try to design new therapies there, that instead of just 2 or 3 companies that hold patents and that were involved in what were zinc finger nuclease tools about 12 years ago, now there's hundreds of labs that apply CRISPR-Cas tools. And that means you have competition, you've got parallel efforts, you have a critical mass of experts that discuss and that bring things forward, so that in the last 5 years alone, since the 2019 and 2019 prime editing publication, there's been an explosion of new startup companies, of new papers, of new applications of these genome editing techniques. And it's not just that they become more safe, because that's one thing. You develop these new technologies for genome editing, and you find out they do things you don't want to happen in the patient, or rather in the model systems before you go in the patient. And then you can fix those things. You can say in the mouse or in the cells, we want to make a certain modification, but we put other modifications. So how can we avoid these? And the tools are being optimized for this.